So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir. Now in today's lecture we are going to see how to solve a problem in which we have to find a subarray whose sum will be s. Okay. So let's take one example and see what actually the question is saying. Here we have an array in which we have 1, 4, 20, 3, 10 and 5. Okay. And the s will be 33. Okay, so we have to find a sub array in which the sum should be 33. Okay, now if you see inside this array, if we have this sub array 20, 10 and 3, okay, then the sum will be result to 33. Okay, so this is the answer in which we have to find the indexes of first and the last element. See, I hope you know what actually the sub array is. Okay, so sub array is nothing but a part of an array in a continuous order. Okay, so it can be a single element, also it can be all the elements present in a sub array. Okay, but the thing is that it should be in a continuous order. I hope you got this. If you don't, then I'll recommend you to please watch my previous video. In that I have explained what actually the sub array is and how to find all the sub arrays. The link will be in the description box. Now let's see how we can solve this problem. So as usual, first approach or the brute force. So approach 1 or the brute force. Okay, I forget to mention that the index 0 1 2 3 4 5. So in this we have to return 2 comma 4 because from 2 to 4 the elements are present in which the sums lead to 33. But let's take s as 16. Okay, we can see that none of the subarrays are actually having the sum of 16. Okay, so in this case we have to actually return -1 comma -1. Okay, now the first approach will be as usual brute force. Here we have to find each and every subarrays. Okay, and I hope you know this, that how to find the subarray. See, basically we will have 3 for loops. Okay, so the first for loop will be running from I equals to 0 and it will be gone till n. Okay, inside this we will be having a variable start in which the value of I will be start. Okay, then we are going to have second for loop in which j will be running from I and it will be gone till n. Okay, and inside this we are going to have an end variable. Okay, and the value of end will be j. Okay, now we have start and end. So let's say if we have start here, okay, and the end is here, so we have to iterate from start to end. That means 1 to 4. Okay, inside this what we are going to do, we are going to find the sum as well. Okay, on the go. So we are going to have third for loop in which k will be start and it will be gone till less than equals to end. Okay, don't forget. Now here we are going to find the sum. So sum plus equals to a of k. That's it. Okay, don't forget to have a sum equals to 0 at every iteration of third. Now here we are going to match if sum is equals to s or not. If the sum is equals to s, then we found a subarray whose sum is equals to s. So just return new int. Here we are going to pass start and end. That's it. Okay, and let's say if the sum is not equals to s, even after running all the for loops, then we are going to simply return -1. So return new int -1 comma -1. That's it. Okay, now if we observe this approach, or this code, we can see that there are three for loops, right? So in all the for loops, they are actually approximately going to 1 0 to n, that means n times. Okay, so the approximation will be order of n square, sorry, order of n cube. So the time complexity will be order of n cube. And if you talk about the space complexity, it will be order of 1 because we didn't take any extra space. Okay, so I hope you got this approach, but we can see that the time complexity is very huge. It's order of n cube. Okay, so we have to optimize this. Now let's see, let's observe this approach only. See, in this approach we are actually having this for loop for having a start, this for loop for having the end. Okay, so the two boundaries. Now for the two boundaries, let's take this. For the two boundaries, let's say this is the 2 and 4. Okay, so we are actually having one more for loop to iterate and get this sum. So let's say if we come up with another approach in which start is here, end is here. Okay, and just for simple calculation, if we found out this sum from of this, so this for loop will be eliminated, right? Only these two for loops will be remaining, right? So due to this, here it will be simple order of 1 because we will be actually coming up with the another approach in which this for loop will be cancelled out. Okay, and here in this place only the calculation will be there. Okay, so here only order of n will be there, and for this it will be order of n order of n, so it will be turn out to be order of n square, right? So let's say that how we can eliminate this for loop. Okay, and come up with the calculation method. See, so approach 2. So this will be happen only with prefix sum. I hope you know this, what is prefix sum. If you don't, again I'll advise you to please watch my previous videos as well. So what actually prefix sum is, I'll give you a quick glimpse. See, here we will be having an array, the same array, 1 4 20 3 10 and then 5. Okay, this is an array A, and let's create a prefix sum as well now. So prefix sum will be nothing but, for this it will be the sum of this elements till this point. If we talk about this, if we talk about this value, it will be the sum till this point. If we talk about this element, it will be the sum till this point. Okay, that means 1 plus 4 plus 20 plus 3. Okay, I hope you know this now. So 1, this will be 5, this will be 25, 28, 38 and then 43. Okay, now how we can create the prefix sum array? It is quite simple. See, at pf of 0, that means this, we don't have to calculate or we don't have to do the addition, right? We have to simply copy this element here, right? But for this element, what we have to do, we have to take this element and we have to add it with this, right? Then only we will get 5. If you talk about this 28, we have to take this element 25 and we have to add it with 3, then only we will be getting 28, right? So first create the prefix sum array. So int pf equals to new int, this size will be same as of a. Now pf of 0 is nothing but a of 0. Got it? Now we will be having a for loop in which I will be running from 1, not 0, 1. Why? Because in pf of 0, 1 is already present. So I is less than n, I plus plus. Now pf of I will be nothing but, say for this, pf of I is nothing but sum of pf of I minus 1 plus a of I. So pf of I minus 1, the element present just on the left hand side, plus a of I. That's it. This is the prefix sum array. Okay, now we know that since here the value of s is 33, okay, the the sub array is this, right? So now, as I said that these two for loops will be same in the second approach only, or right, we are just going to eliminate this. So let's say start is here, end is here. Okay, now till this point the sum is 38, right? And what if we just subtract the element which is just previous than s, right? So if we subtract 5 from 38, we will be getting 33 as an answer. Okay, so for I will be running from 0 to n, then start is I. Again we will be having for loop in which j will be running from I to n. In this end is equals to j, right? Now we have to eliminate the third for loop, right? So what we will do, we will be calculating the sum. Sum is equals to pf of end minus pf of start minus 1. That's it. Okay, but the thing is that let's say if the start is 0, s is here and e is here. Okay, now if we follow this line, start minus 1, that means 0 minus 1 is minus 1, so we will be not able to get pf of minus 1, right? So here we have to have one condition. The condition is if start is equals to 0, then the sum will be simple pf of end, right? It's obvious. Else if the start is not 0, then sum will be pf of end minus pf of start minus 1. Got it? Now here we are going to have if condition to check if the sum is equals to s or not. If the sum is equals to s, then we have to simply return start and end. That means return new int start end. That's it. So we can see that here we have only two nested for loops. And at last, if the sum is not equals to s, so we have to simply return minus 1. So return new int minus 1 comma minus 1. That's it. Okay, now here we can see that we have just two for loops, so obviously the time complexity is order of n square. People might think that what about this for loop? See, this for loop is independent, okay, and these two for loops are actually dependent on each other. That means this for loop is actually dependent on this, so due to that it will be n square. So mathematically it will be n plus n square. Okay, we have to take the dominant term, so it is n square. And if we talk about the space complexity, it will be order of n. Why? Because we have taken the extra space, that is pf. But the thing is that, let's say if the area array a is final in terms of Java, right? It is not actually, we can not modify it, right? So we have to use this. But if we can modify it, or let's say if it is not final, then we can simply manipulate this array and make it as prefix sum. Okay, so in this case the space complexity will be order of 1. I hope you got this. But still, even if it is let's say a is not final, so space is constant, but we can see that the time complexity is n square, which is quite huge still. So again we have to come up with another approach. Okay, approach 3. Okay, now since we are actually learning the two pointer technique, okay, so this problem will be solved efficiently using two pointer technique only. Okay, so let's have an array 1, 4, 20, 3, 10, and 5. Okay, s is 33. Okay, the l pointer 1 is pointing at the index 0, and r will be also pointing at 0. Okay, so we have to calculate the sum of l and r. Okay, it will be simple 1. So sum is equals to 1. Now we have to compare if the sum is actually greater than or equals to or lesser than 33 or not. We can see that this sum is actually lesser than 33. If it is lesser than 33, then we have to increase our boundary, right? If we want to increase our boundary, we have to simply increment the r. I hope you got this. Okay, when we increment the boundary, we have to also consider the element, that is 4. So we have to add 4 in the sum. So this will be 5. 1 plus 4, that will be 5. Again we have to compare with 33. We can see that 5 is lesser than 33. So again we have to increase our boundary. That means do r plus plus. Okay, again do, let's add 20 in this 5, so it will be 25. Again compare with 33, still 25 is lesser. Increase the boundary or do r plus plus, right? Include 3 in 25, that will be 28. Still it is lesser than 33. Increase the boundary, that means r plus plus. Okay, r is pointing to 10, or let's say at the index 4, that will be 38. Here we can see that 38 is actually greater than 33. Okay, but it is not equals to. Now we have to reduce our boundary. Okay, since we want to reduce the boundary, then we have to do l plus plus. Okay, so we have to shift here. Now the thing is that when we are actually shifting the l, first thing we have to subtract this 1 from 38, then only increment the l. Okay, so if we do that, then 37 will be the sum. Okay, now here we can see that 37 is greater than 33. Correct. Again we have to decrease the boundary, so do l plus plus. L will be pointing here. Before shifting the l to the right hand side, first decrement, or let's say first subtract that element. So 37 minus 4 will be 33. Then compare with 33, we can see that it is equals to. When it is equals to, simply return l and r. That's it. Okay, so the pseudocode will look like this. Here l will be 0, r will be n minus 1, and the s will be, sorry, sum will be a of l. Now we will be having while loop in which the r should not cross n. Okay, now first we are going to check if sum is equals to s or not. If it is equal, then simply return new int L comma R. Okay, now else if, see, if this sum, this is the sums, okay, and this is S. If this sum is actually lesser than 33, then we are going to increase the boundary. That means R plus plus. If this sum is actually greater than S, then we are actually decreasing the boundary. That means L plus plus. Okay. So if I say sum is actually greater than S, here in this case, we are actually doing L plus plus. But before that, what we have to do, we have to deduct that element from the sum. So sum L minus A of L plus plus, right? Else do R plus plus and sum plus equals to A of R. Okay, let's take one example where the S will be different. Okay, because I want to show you something. Let's say, the S is 100. Okay, L is pointing here, R is also pointing here. Sum will be 1. Now 1 is actually lesser than 100, right? So if it is, then we have to do R plus plus. R will be pointing here. Then we have to add the 4 into it. So 5 is again lesser than 100. Do R plus plus. Okay, we have to follow this. Don't forget, we have to follow this only. So let's include the 20 in it. So 25 is again lesser than 100. So do R plus plus. Let's add 3 to it. 28 is again lesser than 100. Again do R plus plus. R is pointing here. Let's add 10 to it. So 38 is lesser than 100. Again do R plus plus. So R will be pointing here. Let's add 5 to it. So 43 is lesser than 100. Let's do R plus plus. Now see, R, the value of R is 5. The value of N is 6. Okay. We can see that 5 is actually lesser than 6, right? So it can go inside this while loop. Sum is 43. S is 100. This will fail. It will check for this. Sum is greater. No, it's not. So it will fall under this. Now here it is saying that do R plus plus. If we do R plus plus, the value of R will be 6, and we have to basically add A of R, that is A of 6, into sum. But we can see that there is no A of 6, right? So we have to have one if case here. So if R is equals to N, then just simply break it. You don't have to go further. Otherwise, do sum plus equals to A of R. That's it. Okay. So in this way, we are going to solve this problem. Now the thing is that if you want to consider the time complexity, here we have only one single while loop, right? So the time complexity will be order of n, and we didn't take any extra space, so it will be order of n. Okay, so in this way we can solve this problem. I hope you got this. If you don't, I'll advise you to please try run it by yourself. Okay, so that's it from my side. I'll see you in the next video. Till then, keep practicing.